Good day. Let us now continue solving for the force in member XY. This is our given thrust, and remember, we are going to solve for the force of this member XY. So what we're going to do is to consider passing a section through these members of your given thrust, and we're going to isolate this section, thus giving us this section. Initially, you were able to solve for AV as 37.5 and the horizontal reaction at point A as equivalent to 10. That is 10 kilonewtons and 10 kilonewtons, because we are sort of trying to just consider this particular section of your section AA. It's our section AA. So this will be the part of the section that we were able to consider in our section. We are using method of sections in trying to solve for the force in member XY. This will be our member XY. Okay. In solving for theta of your member XY, this is our theta. This is the angle theta of member XY because it is inclined from the horizontal. This is not the section AA. This is 10 kilonewtons, this is 10 kilonewtons, that's 10, and the reactions initially was 37.5 vertical and horizontal reaction, which is equivalent to 10. Remember that we have to get the components of XY, and XY has a component of XY sine theta and XY cosine theta. However, how do we solve for theta? Theta is taken from this triangle, which is actually this triangle here. So yeah, we consider triangle X, Y, and Z. This is our triangle X, Y, and Z. So theta is taken as tangent inverse, this one here, tangent inverse of YZ, that is YZ all over XZ, okay, all over XZ. And how do we solve for YZ? YZ is 4 plus H. Let's assume that this value is H. This is 4. This is 4. Remember that is 4. Here is 4. Here is 4. And this small part here is now equivalent to H. That is H. This one would have to be H. Therefore, YZ is 4 plus H. And XZ was already given as 4. That's already given as 4. Your XZ is 4. So solving for H, by ratio and proportion, you have H is to 8. That is H is to 8. Here is H is to 8. That is 8 because that's 4 plus 4. As 4, this is 4, or this one, that's 4, is to 12. Thus, giving a value of H as 32 over 12, or that's 8/3. So since that is 8/3, YZ would be 4 plus H, which is 4 plus 8/3, giving you 20 over 3. Therefore, inverse tangent of 20 over 3 divided by 4 would be equivalent to 59.04. It is 59.04 degrees. Okay. Hello. Now we would now solve for the components of XY, whose components of XY is XY sine theta, because that's the vertical component similar to this, and the horizontal component, which is XY cosine theta. Remember that theta is 59.04 degrees. Now, once you got the components of XY, which is this XY cosine theta or XY sine 59.4 for that, and this is your XY cosine theta, XY cosine 59.04. Now, from here, we were now able to transform it to this one. That is because we have to get the moments where these two forces will intersect, which is supposed to be at this point. Prior to solving for the moment at this point, let us solve for the intersection of these two forces, which is supposed to be at this point O. This is how it's done. So this section is similar to this section. Okay, let's remove this first. So solving for f, we have this triangle similar to this triangle, because this line has a slope which goes this way all the way to this point, and this force also has this line which intersects to this point. The reason why we want to have the moment at point O, because we want to eliminate the lever arm of the top chord and the bottom chord from this section, from these forces, okay, on your top chord and your bottom chord, thus leaving the value of xy. So how do you solve for f? This is 4 all over f plus 4. This vertical over horizontal, or the slope. The slope of this line is equal to the slope of this line. This is equivalent to 4. Remember that is 4. Here is 4 all over 12. That's 1, 2, 3, and that's 4 each. There are 3, so it's equivalent to 12, thus giving f as equivalent to 8. So let's go back to this figure already, where we want to solve for xy, because we were already able to solve for the components of xy, taking your moments at point O. We know that is 8 from this point to 37.5, and that is 4 meters and 4 meters. Remember that 37.5 was initially solved, and we also have here a force which is equivalent to 10 kilonewtons. However, that 10 kilonewtons passes through point O, so therefore it has no lever arm, and eventually it won't be considered in your equation in taking your summation of moments at O, wherein it is equivalent to 0, because this system is in equilibrium. So when you take summation of moments at O, you have xy sine of 59.04, this is the value, and the lever arm from this point to here is 8 plus 4, which is equivalent to 16. And you have, that's going clockwise, and you also have 10. This is 10 times 16. But before that, we have xy sine cosine 59.04, wherein the lever arm is 0 here. So with 10, the lever arms also, they are eliminated. And we have 10 multiplied by 16, which I mentioned a while ago. You have 10 multiplied by 12 minus, remember, these are forces going in the clockwise direction, these ones. And the opposite one is going 37.5, and the lever arm is 8, so it's given to 0. And simplifying this equation, you will come up with xy equivalent to 1.458 kilonewtons, or 1,458 kilonewtons. That is the force of xy. And remember that axial stress is force all over area. Therefore, the axial stress of member xy, this member xy, this one, that's your member xy, okay, is equivalent to 1,458 all over an area which was given as 500 millimeters squared. So the area of the cross-sectional area of your member xy is 500 millimeters squared, giving you 2.916 megapascal. And remember that our assumption that goes towards the joint here, towards the joint, is correct because of a positive answer, and that is supposed to be in compression. It's a compressive stress. It's being pushed towards the point, and you call it under compression.